So we'll be presenting our ES116 project right now, and we have made a gas leak detection and emergency response system which works with an MQ2 sensor and a fan, three LED lights, a buzzer, a servo motor, a gas valve and ESP motor. So it detects the gas leak if there's any, and then it turns off the fan, which is the ventilation system. Then it switches off the valve so that no gas comes in, and switches on the LED in stages, and also sounds the buzzer. Why we decided to make this project is essentially that gas leaks is a very serious concern in India. There are hundreds of cases throughout the year, and no life should be lost in such a trivial issue that can be solved in this apparatus which costs about only 1,000 rupees. So now we'll be demonstrating the circuit.
So this is our circuit, and these are the two USB cables. One is connected to the Arduino and one is connected to the ESP. And this is the ESP. ESP is connected to the GPIO board. The buzzer and LED are on the GPIO board. It is also connected to the fan through a transistor.
Now we are using ESP8266 just to provide signal to the MQ2 sensor and the servo motor, and we are using Arduino just to power the whole circuit. And for the ESP8266 we just need 3.3 volt, not more than that, or else it will get short circuited. And we use the hot glue gun to attach the gas valve with the flap of the servo motor. As you can see, these are the gas readings. Now we will stimulate it with the help of gas lighter, and after lighting up the gas lighter, the gas leakage will be detected and the LEDs will get on, as well as the DC fan will also on to ventilate the gas leakage, and the servo motor will close the valve. When the gas levels becomes normal, the servo motor will open the valve, and there will be no buzzer, and the fan will also get off.
The transistor in our circuit works as a switch. Since the ESP can't directly drive high current devices like a fan, allowing current to flow from collector to emitter. Now the flyback diode. This is essential. When the fan is suddenly turned off, it releases back EMF, a reverse voltage spike that can damage the transistor or cause the ESP to glitch. Therefore, the 1N4007 diode placed across the fan terminals safely absorbs that spike, protecting the circuit.
This project is a direct application of several foundational concepts from the ES116 course. So we implemented transistor switching, a concept that was reinforced through both lectures and the lab work, that we had to control the high power components like the fan through a transistor. The MQ2 sensor, the working of that also required analog to digital interfacing, and that was also taught in lectures. Furthermore, our understanding of circuit protection mechanisms, particularly the use of flyback diodes, came from the diode lectures that had taken place. And the overall system integration, like the hardware part and the software part, was facilitated through the multiple labs that had taken place in the ES116 course, like for example the Arduino lab and all of the other labs. So this combination of theoretical knowledge with practical execution to solve real world problems was taught in ES116 course. In the future, this system can be enhanced for real world deployment by integrating it with a module that can send SMS alerts in areas without Wi-Fi, and the servo will be replaced by a high torque motor or something that can actually cut off the gas supply line. Additional features like a voice alert system instead of the buzzer and a battery backup for power outages can further increase reliability, and a fireproof enclosure can actually evolve the system into a comprehensive safety solution for homes and industries.